We need to show the derivative of y with respect to x, that value is equals to 1 whenever x is given by x and y are both given by its parametric form. That means they depend on the parameter t. So let's begin. We'll start with our first function, which is given by x equals to sine inverse of 2t divided by 1 plus t squared. Now what we have to do, we have to find out derivative of both sides with respect to t. But before that, we'll try to simplify our inverse sine function by making a trigonometric substitution. So let's make the substitution. That means if we take our value t to be equals to tangent of theta, then let's work with that. So we have 2 times t divided by 1 plus t squared. So this will become equals to 2 times tangent of theta whole thing divided by 1 plus tangent squared theta. Now in the denominator, 1 plus tangent squared theta, that's a standard trig identity, which is given by secant squared theta. So we have 2 tangent of theta divided by secant squared theta. Now 2 times tangent of theta, so tangent of theta can be converted to its sine and cosine because it's the ratio of sine and cosine theta. And we have 1 over secant squared theta, which is actually cosine squared theta once it goes to the numerator. So 1 cosine theta from the denominator and 1 from the numerator goes away, and this leaves us with 2 times sine theta times cosine theta. Now 2 times sine theta times cosine theta, this is another trig identity. So whenever we have sine of 2 theta, its expansion is given by 2 times sine theta times cosine theta. So that means we have reduced or simplified 2t over 1 plus t squared and made it equal to sine 2 theta whenever we have t equals to tangent of theta. Now what we'll do, we'll replace this value in place of 2t over 1 plus t squared in x. So that means our x value will be equals to sine inverse of sine of 2 theta. Now sine inverse of sine 2 theta means we have 2 times theta. Now we started out by considering t to be equals to tangent of theta, which means that theta must be equals to the inverse tangent of t. Fine. We can replace this value here, and now we have x equals to 2 times tangent inverse of t. Fine. So we have finally simplified the value of x. We'll label this as equation number 1. We'll come back to this in a moment after we tackle with y. So for y, we have given by our function y is tangent inverse of 2t divided by 1 minus t squared. So here we're going to use the fact that whenever we have tangent inverse of x and we add it to tangent inverse of y, so this value is actually equals to tangent inverse of x times x plus y divided by 1 minus xy. So that means if we replace the value of x and y with t, then in our case we will have, so this will become tangent inverse of t added to tangent inverse of t, which will be equals to tangent inverse of, so we have in the numerator t plus t, so that's 2t divided by 1 minus x times y will become t squared. So we can say that 2 times tangent inverse of t, that's actually equivalent to tangent inverse of 2t divided by 1 minus t squared. So in a sense, we can say that the y is actually 2 times tangent inverse of t. So we have also obtained a simplified form of our function y, which is given by 2 times tangent inverse of t. We're going to label this as equation number 2. Fine. So we have obtained x equals to 2 times tangent inverse of t and y is 2 times tangent inverse of t. Now what we'll do, we'll find out derivative of x with respect to t. So we'll use equation number 1 here. The derivative of x with respect to t is actually 2 times derivative with respect to t of the inverse tangent function, tangent inverse of t. Now tangent inverse of t, its derivative is 1 over 1 plus x squared. So this is the value of derivative of x with respect to t. Similarly, if we find out derivative of y with respect to t, so since this is also 2 times tangent inverse of t, we'll also get 2 divided by 1 plus x squared. We'll label this as number 4. And finally, in order to find out the value of derivative of y with respect to x, all we have to do is take derivative of y with respect to t and divide it with the result obtained for derivative of x with respect to t. And since both of them are the same term, so we'll get the value 1. And hence we have successfully proved that derivative of y with respect to x, this value is equals to 1. Hence proved.